Hello. Let's talk about how we can actually hold off some tasks from main thread to other thread and let the main thread breathe a little bit. So actually the fact that I wrote this talk was going back to maybe 2 years ago when I was searching about like how many people around the world like connecting to the internet, and I found out that around 50% of the population are connected. And when I came back again to the statistic, I noticed that after maybe 1 and 2 years, 5% more of the population are now connected, more than what they are connected like 2 years ago. And interestingly, around 90% of these people are connected to internet via their mobile phone. I mean, they're just checking our website, our web application via mobile phones. And when I'm talking about mobile phones, I'm talking about a lot of different phones. It's not just a good quality phone like iPhone or like high-end, high quality aspect, hardware phones. It's also some phones that they are looking good, very fine, but the hardwares are not as powerful as, phones like iPhone, for instance. For instance, Nokia 2. So people are connecting with these phones for sure, and we are shipping our complex application to them every day. And in fact, so when it comes to even desktop, so we have different laptops with different specs and, different desktop with different hardware. And time to time, when we ship our complex application, we show this unresponsive page to our user, which makes them so frustrated, right? So they don't like to see these unresponsive or unreliable pages. But it comes to our mind that what can we do? Why we need to care? So what should we do? The thing is that we need to care about all of our users. We need to care about all devices. We need to care about everyone who is connected, even though you are actually shipping an application for like a local, let's say, a market. There are still some, you need to probably get some statistics, but there are still some, devices that you need to cover and you need to support. In this talk, I'm going to explore two options that we have in the browsers right now: an underestimated one, WebWorkers, and a new one, WebAssembly, and see how we can actually hold off some of our logics to these threads and then free up our main thread and let our user be more happy. Let me introduce myself. My name is Majid Haijan. I'm based in Oslo. I am a passionate software engineer. I do a lot of JavaScript and front-end, as well as Dart and Flutter. So I'm also author and instructor of a couple of courses and tutorials, as well as author of some books on the internet, especially about PWA. In my spare time, I'm also organizing quite a lot of meetups and conferences. This is my passion. And you can find me on internet with this handler almost everywhere. So let's go back to our main thread. So when we are talking about our main thread, so we are talking about quite a lot of things which is happening there. When it comes to main thread, so imagine this picture. It just shows you like a main thread does. It has event loops. It just download, JavaScript, parse it. It does styling. It does layouting. It paints, repaints, compositing, and a lot of things like that. So, if you're thinking about main thread, it's a lot of tasks on its shoulder. And by creating complex application, we are even adding more. And in fact, we are expecting to deliver us 60 FPS, 60 frames per second. And that makes it even harder for main thread to take all of this responsibility. Let me tell you a quick budget. So if you want to actually ship 60 frames into 1 second, it is around 16.6 milliseconds that we have a budget, right? So let's talk about this budget in different phones. If you're talking about like a very good phone with high spec hardware compared to a low spec hardware phone, you see that this budget in one phone is quite okay, and in another phone maybe it's on the edge, and another phone it's just overpassing our budget. So that's the time our users seeing janky frame. And that's even not there. So if you're talking about 60 FPS in different screen rate, like 120 hertz, it's even worse. Like in 90 hertz, you even have less than 60. You have around 11 milliseconds. And in 120, you have even less. So that brings this unpredictability to our application when we are delivering. So in fact, we don't know like if this application right now, if we are actually running them on different devices, are they going to run as smooth as what we are testing on iPhone, or maybe on a powerful desktop? So here is where I have to say that this is our responsibility. This is developers' responsibility to handle all of these unexpected and reduce the bad user experience by just freeing up some task from main thread to other thread. And in fact, we have a very old friend, like back maybe 2017 or 2012 afterwards, almost all browsers have a good support of that. WebWorker is very underutilized tools or API in the browser. But let's talk about it. So quickly talking about WebWorker, it's similar to a headless, let's say, browser, right? So it just run everything in isolation. There is no variable that we can share, and you can actually you can even run them in parallel. And the only thing is that this is headless because it doesn't have access to DOM, and that's one of the characteristics of this browser, right? So if you're talking about quickly WebWorker, is that okay? So the way that it works, you're just spawning a new instance of WebWorker, and then you're communicating with that via post messaging system. So, and WebWorker has the exact same characteristic as main thread does. So it has like message queue and all of the things that you have. You can even run WebAssembly and things like that. So, but then if that is easy, then why don't we use that? Because, this post messaging system might not be like the way that we really like to work in daily work, So we are very used to sync and promise based, or maybe sometimes callback. Let's say these days, promise based, way of working, a way of coding. And it would be very nice, instead of this post messaging system, we can just get an access to worker thread quickly and then get a response afterwards, right? So here is where this library Comlink comes in handy. So with this library, the way that we actually spawning WebWorker is quite easy. So we just spawn our worker, and then we wrap it with Comlink, and then we get access to the service or the functions that we are exposing from from WebWorker. And the good thing about is that, as you see in the code example, so Comlink makes it promisified. It promisified all of the functions, and you can just await for the result and then just do something with that. So in a worker JavaScript file, you also need to expose what you want to actually expose to the main thread here, and you just say to Comlink, hey, these are my function, or this is my object which I want to expose. In fact, if I want to give an example in React, let's say, when we have spawning a worker here, we just wrap it and then assign it to a variable, and then here is where we have our function in a worker, where we have like a heavy computation task. Like I want to sort let's say an array. So here I can simply just send this array to the worker and just do something and get the result back and set it out. And if I'm done with that, I can also terminate my worker. And let me just tell you this right now. So this is awesome, right? What we can do now, we can just differentiate between our business logic. Let's say we can actually hold off our business logic to our worker thread somehow, and we can have our UI logic to main thread. And this is actually how maybe mobile developers like in Swift or Android usually works. You have UI thread where you have access to UI and you can manipulate that. And in a main thread, maybe in browser, we can somehow mock that. We can say, hey, this is main thread. I just have access to DOM and I want to manipulate it, right? And then there is any logic that I can hold it off to other thread and just do something with that and then get the result. And then again, in main thread, I can manipulate it. An example is like we are probably familiar with Redux. It's pretty popular, state management pattern, especially in React, ecosystem. So the way it works quickly is that you have your reducer, which might be actually blocking, and because it's synchronous, it just want to give you like the store and like your state, your unified global state. And then you have your view and action where you dispatch this action from view and the reducer just gives you this store and you have your global store everywhere. What we can do with that, as an example, we can keep the part that is related to DOM and related to UI in a main thread, like view and action. And we can hold off the part that is logic and might be even blocking, and then move it to the worker thread. Like reducer and store can be kept over there, and then we can keep action and view in main thread. Let me tell you an example here. If I want to write this in an action with worker thread, this can be my worker JavaScript. So this might be my reducer. First of all, I have some action here, the type of action, and I do some stuff. I deliberately here in this example, like make 3-second delay to just do something. I just want to show you like how we block sometimes UI. And then here is my store worker.js and my application.js, like where I expose my store. You see that I create a store from this reducer. And in my main thread, application.js, the way that we usually work, well, without a web worker, we just use the same method to create our store. But if we have a worker, then we actually instantiate our worker and wrap it with Comlink. And here is where we have access to our store with a little bit of modification. By the way, don't worry about the sample code. You have access to all of these slides and all of these sample codes afterwards. You can go ahead and read them once more. So then, if I want to show you an example right now, so here is an example. So when I have my main thread, and if I dispatch an action, when reducer is working, then the UI is blocking. But if you look at the worker one, I just dispatch an action. I'm just trying to change something. But if you see the animation, my main thread, it's not blocking because there is nothing. It's breathing right now. So it's no problem for the main thread to just do some other UI stuff. But when I'm actually moving this reducer to my worker thread, that is how it works simply. But you may ask right away a question. Does it even faster? Well, I mean, let's have a look at that. If you have this UI thread, let's say main thread in our example, so if you are spawning a new worker thread, you're actually adding a little bit overhead here for instantiation, opening, post messaging system, and things like that. So in fact, it might not be faster, sorry, but I can say that it's more reliable. As you saw in the example, you don't block your UI. You're just sending these messages, these business logic to a worker thread and just get the response back to your main thread. And that makes it more reliable and less unresponsive UI. And well, it might be even faster. Yeah, I can tell that. If your phone, or let's say in browser you have, in desktop you have several cores, yeah, it might be a case that you run this in parallel. I have another talk about parallelism in JavaScript, so you can watch that later. So it runs in a different core at the same time, and it might be even faster, but you don't know as a web developer for sure. And it might be also a little bit risky in that case. So let's move on to the next example here. Another example here, you see that I want to actually sort a heavy list here with Worker. And without WebWorker, you see that I'm blocking my animation UI here in this case. And, it's very unpredictable, and my UI and my user is not going to be happy for that. Another friend of us right now, these days in the browser, with a very good support in most of the browsers, is WebAssembly. But when it comes to WebAssembly, we quickly think of languages like C, C++, Rust, these type of languages. I'm not going to talk about the theory behind it, because you probably have heard about WebAssembly and you know the idea behind it. But when it comes to a JavaScript developer, I have to say, well, it is fun to learn another language, but sometimes maybe we don't have time for a project. Maybe we are rushed to do something, and it's a little bit risky to just go with another language that we don't know, right?